started with a warm-up. So take a moment and try the warm-up, pause the video, and then play to check your answers. So the first one, solve and graph on a number line. So if I need to get that -2 out of there, so I'm going to divide both sides by -2. If my pen's going to work for me here. So I'm going to divide both sides by -2. So then I have the absolute value of 3x minus 7. Absolute value, I just divided by a negative, so I'm going to remember to flip the inequality, and -8 divided by -2 is +4. So now I have an absolute value by itself less than or equal to 4. Okay, so I can go ahead and set up my inequalities and solve this. This is less than when we write the one long inequality. So I'm going to set that up. Notice I now removed the absolute value because I just applied the definition. So I'm ready to solve, adding 7. 7 plus -4 is 3, less than or equal to 3x, less than or equal to 7 plus 4 is 11. So dividing both sides by 3, I'm getting 1 less than or equal to x, less than or equal to 11/3. So that's my solutions. And graphing that on a number line, 1 is smaller than 11/3, which if you want to change that to 3 2/3, that's fine, or just 11/3. These are solid points at 1 and 3 2/3, and then I'm shading in between. Remember, if you decided to write this as two separate inequalities, that's fine, but you would need the word "and" in between the two inequalities. So there's our solution. Number 2. Now, number 2 actually takes a little bit of thought rather than going through the process. And the reason why is because we have an absolute value greater than a negative. Well, you learned in Algebra 1 that you can't ever have an absolute value equation. Like if this was an equal sign, you can't have an absolute value equation equaling a negative because absolute value will always give you a positive output. So in that case, if this had been just an equal sign, then we would say no solution because I can't have an absolute value which has a positive output. I can't have that. So I can't have an absolute value inequality that's going to come out positive. The absolute value on the left is going to come out positive. That I can't have equaling a negative number. So that would be no solution if this was an equal sign, but it says greater than. So I know when I see an absolute value that's greater than or less than a negative, I know that I'm not going to use the same approach that I did here on the other problem in number 1. So because I'm not going to use the same approach, this is more of just a thinking through the problem. So if we know the left-hand side here, this absolute value, if we know that that's going to be a positive outcome, what I'm just going to think is positive outcome, is that going to be greater than or equal to a negative number, -8? Well, yes, a positive is always going to be greater than or equal to -8. So it doesn't really matter if I put 0 in here, a negative number in here, a positive number in here. That output on the left-hand side of the inequality will always be positive, and positive numbers will always be greater than a -8. So that means that all x values are possible solutions for x. Because again, no matter what I stick in there for x, this has an absolute value around it, which means it'll be a positive output, and positives are always going to be bigger than -8. So my solution is negative infinity is less than x is less than infinity, or all reals. You could write all reals. Now, had the problem been the absolute value of 2x plus 5 is less than or equal to -8, same thing. The reason I know to kind of think this through rather than going through the process as I did over here is that I have an absolute value and it's less than a negative. Anytime we have a negative over there, then you're going to just think your way through it instead of using the process. So I'm thinking my way through this. This is going to be positive. Are positives less than -8? No, a positive is never going to be less than -8. So this would be no solution because there are no values for x that I could substitute in here and make this left-hand side smaller than the right-hand side, -8. Okay, now looking at the number one again, that one does have a negative on the other side of the inequality, but be careful, because we divided through by a negative, it lost its negative. And now when the absolute value is by itself, now it doesn't have a negative anymore. So this one I solve normally. I don't have to think about it like I did these. These though, when the absolute value was by itself, then we were comparing to a negative, either greater or less. So that's when you have to think about it, and it's either going to be all reals or no solution. But any other time when it's just comparing an absolute value to a positive number, then you'll just go about solving as normal. Okay, so that takes care of the warm-up. So then we looked at graphing this graph. And this actually is a function. This is in function notation, and we call this a piecewise function or a piecewise graph. And so the way that we'll approach that is we'll take it one at a time. I'm going to start by looking at this top equation. And remember, realize that says f of x equals. So remember when we talked about functions, we said that f of x is the same thing as y. So I'm just going to write that as y equals 2x plus 1. So y equals 2x plus 1 is a line. I am going to graph that line, but I'm not graphing the whole line, I'm graphing just a piece of it. And specifically, I'm told the piece that I'm supposed to graph. So the piece that I'm supposed to graph starts at -1. So I'm going to input -1 into my equation for x. So when I do that, I'm getting -2 plus 1, which is -1. So the coordinate point, -1, -1, is where this line, y equals 2x plus 1, is going to start. Now, I'm looking at this inequality symbol, though, and it's not equal to. So when I plot -1, -1, I'm going to plot it as an open point. So I'm going to -1, -1, and I'm putting an open point there. Now, I'm looking at the inequality symbol again, and I'm seeing less. Less, if you think about shading on a number line, we know less is always shaded to the left. Okay, so because it says less than -1, I know that from this point that I just plotted, I'm going to graph the other points that are to the left of that point. So I'm now going to look at my slope, and the slope is +2 over +1. Well, generally that means up 2 and to the right 1. But if I go up 2 and to the right 1, then I'm on the right-hand side of the line, not the left. And we just said we want to be on the left-hand side. So I can't perform the slope as normal. I can't rise 2 and run 1 to the right. Instead, I have to go down 2 and to the left 1. Okay, so the opposite of both of those. So instead of rising 2 and running 1, which would take me to the right-hand side of the point, I need to be to the left-hand side of the point. So I'm going down 2 and to the left 1. And I'll do that a couple times, down 2 to the left 1, down 2 to the left 1. And then once I have a few points, I'm going to just draw the rest of the line. So an arrow on that end. So it's like a ray. And that point has to remain open though. That -1 is an open point. So when you draw your line, just make sure you don't go through the open point. So that's the first piece of our piecewise function. Now we're going to graph the second piece, which is y equals -x minus 3. So once again, that is a line, but it's only going to be a piece of a line. So to figure out what piece, I'm going to input -1 in for x. So y equals the opposite sign. I'm inputting -1 for x minus 3. The opposite of -1 is 1. 1 minus 3 is -2. So we just figured out the coordinate point is -1, -2. And that point, I see an equal sign, so I'm going to go to -1, -2, and I'm going to put a solid point. -1, -2, solid point right there. Okay, Now I'm going to look at the inequality symbol and decide, do I want to the left or to the right of that point? So I see greater than. Well, greater than, we know on a number line, is to the right. So I'm going to be plotting the points that are to the right of that point that I just plotted at -1, -2. So I'm going to use my slope to get those points. My slope is in front of the x. So my slope is -1 over +1. So normally, -1 over +1 means we're going to go down 1 and right 1. And right is the direction that I just said we wanted to go in. We want to go to the right of that point. So that's exactly what I'm going to do. I'm going to start at that point, and I'm going to go down 1 and to the right 1 a few times. And then from that point, draw in the piece of the line, which actually is just a ray. And those two pieces together form this function, and this function is called a piecewise function, f of x. So let's try another one. So this time, we're going to graph this function g of x. So I'll start with the first equation, y equals 1/2 x plus 4. So I'm going to input 2 in for x. When I do that, I'm getting 2 times 1/2 is 1, 1 plus 4 is 5. So my coordinate point is 2, 5. And that should be, I'm looking at this symbol, it should be an open point because it doesn't say equals 2. So 2, 5, open point. Now I'm going to decide which way I'm going to graph the line from that point. And I see a less than. So less than I know means to the left. So I'll just write that there to remind myself. So I want to plot some points that are to the left of that point. And I'm going to use my slope to figure out how to do that. So my slope is 1/2, which is normally rising 1 and running to the right 2. But we just said that we want to go to the left 2. So if I want to go to the left 2, then I have to go down 1 instead of up 1. So I'm going to go down 1 and to the left 2. And that will be okay because that's the same thing as going up 1 and to the right 2. But I'll have the correct portion of the graph, which is the left side of that point. So from this point, I'm going down 1 and left 2 a few times. Down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, and so forth. And again, don't go through that open point, and then just draw the line in from there. So that's our first piece. Second piece. So our second piece is simply just g of x or y equals 3, which is going to be normally a line. However, there's only one x value. So x is 2 and y is 3. So actually the portion of the line that we want to plot is really just 1 point. It's 2, 3. It's equal, so I'm going to 2, 3, and I'm putting a solid point. Okay. The last piece that we're going to graph is here. Y equals negative the absolute value of x minus 4 minus 2. So we're going to substitute in 2 to see where we start the graph. So y equals negative absolute value of 2 minus 4, absolute value minus 2. So y equals negative 2 minus 4 is negative 2, minus 2. The absolute value of negative 2 is 2, but there's a negative in the front, so it's a negative 2 minus 2. And negative 2 minus 2 is negative 4. So the point that I need to plot, we inputted at 2, and we got a negative 4. So 2, negative 4 is the point that we're going to plot. And we're looking here, we see less, we see greater than, we don't see equals. So I'm going to put an open point at 2, negative 4. So I'm going to 2, negative 4, and I'm putting an open point. From that point, I'm now going to decide which side I need to graph. So greater is to the right. So I'm going to plot to the right, but I'm noticing this time it's not a line. It's going to be an absolute value graph. So I'm going to figure out where the vertex would be like we did the last couple of weeks in class. I'm looking at this equation and I'm going to figure out the shifts, which then is going to help me get the vertex. So we know that -4 inside the absolute value is right 4, and -2 outside the absolute value is down 2. So if I start at 0, 0, and I go right 4 and down 2, that takes me to 4, -2. And before I plot that, though, I'm going to double check, is that vertex to the right of the point that I already have plotted? And yes, it is. 4, -2 is right here, and that's to the right of the point I already plotted, which is the direction that I want it to be. So I'm going to go ahead and plot the vertex at 4, -2. Now that I have the vertex and the other point, I'm going to go ahead and connect them. Okay, but I know that an absolute value graph is a V, and I do want the whole entire right side of the V because I already have the vertex and part of the left-hand side of the V. I need the whole entire right-hand side of the V. So from here, we're going to graph the other side the same way we've always been graphing absolute value, using the number in the front, which is a -1. So -1 over +1 means from this vertex, I'm going down 1 and to the right 1. And I'll do that a couple times. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and so forth. And now I have the other side of my absolute value graph. And all those together do pass the vertical line test. So therefore, this is a function. This is my piecewise function. Okay. Now, we're going to use the same functions, but we're going to, rather than graph them this time, we're going to evaluate them. So think about what that means. First of all, f of -3 means I'm looking at the f function, and I'm inputting -3. So I'm ready to input -3, but there's two different equations. So the question becomes, do I input it in the top or the bottom? Well, that's for us to figure out. So what I have to do is I have to compare my input, -3, to the numbers that they have listed here. So I have to ask myself, is -3 less than -1 or greater than or equal to -1? Well, -3 is less than -1. So because -3 is less than -1, I'm inputting it into the top equation rather than the bottom. So for f of -3, y is equal to 2 times -3 plus 1. Again, I'm inputting that into the top equation because -3 is less than -1, not greater than or equal to. So -6 plus 1 is -5. So f of -3 is equal to -5. Doing the next one, g of 5, same idea, except for now we're going to g. 5. 5 has to be compared to 2. Is it less than 2, equal to 2, or greater than 2? Well, 5 is greater than 2, which means I'm going to input into the bottom equation. So y equals negative, the absolute value, 5 is what's being input, minus 4, absolute value, minus 2. So y is equal to negative, the absolute value, 5 minus 4 is 1, minus 2. The absolute value of 1 is 1, and I have a negative in the front, so that's -1, minus 2 is equal to -3. So g of 5 is equal to -3. Next, f of g of -2. So we'll start, just like we did composite functions before, we'll start with the inside first, meaning I'm going to go to the g function, and I'm looking at -2 being my input. So if -2 is the input, is that less than 2, equal to 2, or greater than 2? Well, -2 is less than 2. So I'm going to use the top equation. So 1/2 times, I'm inputting -2 plus 4, which gives me -1 plus 4, whoops, which gives me 3. So g of -2 equals 3. So now I'm ready to put that into f, which means I'm looking for f of 3. So f of 3 means I'm coming over here and I'm comparing 3 to -1. Well, 3 is bigger than -1, which means I'm going to be inputting 3 into the bottom equation. So I'm doing the opposite sign of 3's being input, -3, which gives me -6. So f of g of -2 is equal to -6. Okay, and let's look at that last one. So f of -1 is what comes first. So -1 is going into the f function. Well, -1 is equal to -1, which means I'm substituting into the bottom equation. So the opposite sign of -1 minus 3 gives me 1 minus 3, which gives me -2. That's f of -1. And now I'm going to go ahead and put that -2 value into the g function. So I want g of -2. Well, the good news is we did g of -2 right a moment ago. G of -2 we put into the g function, and we said that -2 is less than 2. So we input it into the top, and when we did that, we got 3. So g of -2 we already said is 3, which means my final answer for g of f of -3 is equal to 3. Okay, that was it for notes for Monday. Homework for Monday was worksheet number 4, problems 1 through 6 and 10, worksheet 5 all, and then page 37 all. And then reminder, you do have a test coming up on Thursday and Friday, which means your Unit 1 packet is due on Friday as well.